Great, thank you, Angela. So I'd first like to thank the OEH Seminar team for inviting me to speak today and for everyone that's joining us today. So I hope this presentation will be informative, especially for those of you considering green space exposure in your work, or maybe for those who have a personal interest in the impact of your surrounding green spaces. So today I'll be presenting a portion of my master's thesis research, which examined green spaces and walkability in Metro Vancouver. It was a comparison of green space metrics and measurement methods, walkability, and social and material deprivation. I'll provide an overview of my project and results, and I'll be happy to address any questions. Oops. All right, so I figured we would start off with a poll question. So I would like everyone to answer, what health outcomes have you do you think have been linked to green space exposure? So this can be based on your own interactions with green space or any literature you've read on the topic. All right, so it looks like we have a very knowledgeable group of attendees today because all of you got the correct answer. That's right, all of the above have been previously linked to green space exposure. So that, as that shows, there's an extensive literature examining the role of the built and natural environment has on health of individuals. So in addition to or in relationship with other exposures such as air and noise pollution and extreme heat, both green space access and exposure and walkability have been studied in terms of individual health outcomes. Green space and walkability have been associated with increasing health promoting behaviors such as increased physical activity and social interactions, as well as specific health outcomes, such as a lower prevalence of diabetes, reduced hypertension, and lessened symptoms of depression, anxiety, and stress, as well as more general health outcomes, such as improved general health and reduced overall mortality. And just a quick note on terminology, neighborhood walkability refers to the characteristics of the pedestrian environment that make transportation or leisure walking or active transportation modes, such as cycling, more accessible to individuals. So walkability can be measured by the type and density of destinations to an area. So how many services and amenities can someone reasonably walk to, as well as the pedestrian infrastructure, such as the sidewalks or otherwise safe places to walk. So going back to our overall look on green space exposure and walkability, however, that not all of these studies have found consistent findings. So either in terms of effects on the built and natural environment on health outcomes across all individuals and groups, or when findings are compared across studies. So despite the considerable existing literature examining the role of green space, there's no standardized definition of green space. And some of these metrics are not well correlated with one another, especially part count. And I'm going to get into these metrics later on. And to further complicate the situation, a recent review of 125 green space articles reported that less than 50% of these papers had satisfactorily explained how green space was defined in their study. And other researchers have reported that the use of different green space metrics may result in dramatic changes in the relationship between green space and health outcomes. In addition, although both green space and walkability tend to be associated with improved health, it can be difficult to design neighborhoods that are both green and walkable. And finally, greener and more walkable neighborhoods tend to be more desirable. And these features tend to be more common in more affluent or less deprived neighborhoods. So you might be wondering, why does any of this matter? Well, green spaces and walkability are two modifiable urban design features and are often first to be considered when promoting neighborhood health and sustainability. So increasing walkability in urban green spaces are strategies that have been used to promote improved health in urban areas. Along with these health impacts, increasing green space may help mitigate the effects of climate change, and increasing walkability may reduce the number of vehicle trips, therefore reducing traffic-related pollution and noise. Additionally, neighborhoods with higher material deprivation, low walkability, and low green spaces may be prioritized as possible locations for additional green space allocation, or where infrastructure investments to improve walkability may be targeted. So previous work has typically shown a lack of strong relationship between natural land cover types and park access in urban areas, including Metro Vancouver. However, this phenomenon has not been examined for relationships between park count, NDVI, land cover type, and tree canopy. In addition, although circular and network buffering methods have been compared in terms of walkability, these methods have not been compared for the use of these 4 green space metrics. And therefore, the 3 main objectives of this work were, first, to examine the results of quantifying green space using 4 different metrics, those metrics being park count, NDVI, land cover, and tree canopy cover. And I'll get into how these metrics work later on. Second, to compare the buffering methods, circular and network, and across 2 distances, 400 meters and 1,000 meters. And finally, to examine the relationship between these 4 green space metrics, walkability, and neighborhood level social and material deprivation in Metro Vancouver. All right, so we're gonna have our second poll question. So if I was to ask you what would be the best way to accurately measure green space in a neighborhood, maybe you want to compare a number of different neighborhoods, which measure would you choose? Would you want to look at the number of parks, the amount of tree canopy, the proportion of the area covered in vegetation, or the average density of the greenness in an area? All right, that's interesting. It's pretty split around the different options. And this one was kind of a trick question. So these are all appropriate ways that green space can be measured. And they've all been used previously in the literature, but it's interesting to see that they're all kind of popular. So those 4 potential responses also more or less correspond to the 4 green space measures used in the study, which I'm going to describe in greater detail shortly. But first, I'm going to give you kind of a big picture context of the study. So the study area from this analysis encompassed the entirety of the Metro Vancouver Regional District in British Columbia, Canada, which includes 21 municipalities, 1 electoral district, 1 Treaty First Nation and other non-Treaty First Nation reserves, as well as the city of Abbotsford. The study area included a 5-kilometer buffer surrounding the Metro Vancouver Regional District in Abbotsford, which contains smaller portions of the neighboring Fraser Valley and Squamish-Lillooet regional districts. The study area contains a diverse array of built and natural environment types. This area included nearly 61,000 hectares of protected agricultural land reserve, suburban neighborhoods with low residential density, in addition to the 5th most densely populated urban center in North America, the city of Vancouver. The overall regional population density is approximately 850 persons per square kilometer, with 1/3 of the area designated as urban. So here you can see a series of maps that are just a portion of the study area. So it's approximately the city of Vancouver boundaries there. And here you can see the depictions of the 4 types of green space data used. So on the top left, you can see the tree canopy cover data. So this data was prepared by Metro Vancouver and uses 2014 land cover classifications to calculate the proportion of buffer covered in tree canopy. So in this visualization, darker green indicated areas with higher proportions of tree canopy. Then next on the top right, you can see park count or park locations. So this was calculated using the Metro Vancouver 2016 land use classification data layer. So each parcel in this data layer is classified by the official land use. So parcels coded as recreational, open space, and protected natural areas were identified as potential park areas. And within the analysis completed in this study, only parks with at least 1 hectare of total area were considered to ensure that these areas would be appropriate for active recreation and physical activity, which is consistent with the exclusion of smaller parks in previous work. This inclusion of only 1 hectare in larger park spaces prevents the inadvertent inclusion of green spaces where recreation would be unlikely, such as roadways or sidewalk medians with vegetation, but as a result also excludes intentionally designed parklets and small urban open spaces less than 1 hectare, where residents may engage in social interaction or recreate. And in this visualization, the green areas are designated parks and open spaces, while the light gray represents all other land uses. So the next on the bottom left is the land cover type data. So the study area was classified into 12 urban land cover types using high spectral resolution imagery collected in 2014, also by Metro Vancouver. So the land cover types include 5 types of green land cover, which were coniferous, meaning it contains greater than 75% coniferous tree species, deciduous, meaning containing greater than 75% deciduous tree species, shrub, which was vegetation taller than grass, but shorter than trees, so approximately 3 to 4 meters tall, modified grass herb, which included agricultural crops, golf courses, park spaces, and lawns, natural grass herb, which includes meadows, grasslands, or wetlands. So then these 5 land cover types were analyzed individually, as well as a composite total green exposure variable. So in this visualization, each land cover type is represented by a different color. And then on the bottom right is the NDVI, or the Normalized Difference Vegetation Index, which was calculated using NASA's MODIS satellite data. This data was obtained through the application for extracting and exploring analysis-ready samples portal, and utilizes 16-day average data at 215 meters resolution, and was collected in 2016. The resulting values range from -1 to +1, with low positive values indicating barren areas, while more moderate positive values, so from 0.2 to 0.3, indicating areas with shrub and grass, and higher positive values indicative of healthy, dense forested areas. And negative values typically indicate areas covered with water. And so in this visual, the darker, more vibrant green is depicting NDVI values closer to +1. All right, so for the third poll question, I want you to complete the statement. Blank should be considered when describing the characteristics of your neighborhood. Vote for A if you think you would want to include all the exposures surrounding your home. So for example, you could draw a big circle around your home with it in the center. Or would you want to only include the areas that you would be able to access or walk past? All right, so this is interesting that it's almost, it's pretty close to 50-50. So these 2 options correspond pretty closely to the 2 exposure buffers types that were used in the study, and are both completely appropriate ways to measure the exposures in a neighborhood. This was what we used to attribute how much green space is present in each neighborhood by creating these exposure buffers surrounding each residential postal code. So just to give a little bit of background on that, these 2 buffer sizes were created surrounding each postal code in the study area. So for a total of 57,430 postal codes total, using both circular and network buffers, which I'm gonna explain further. The 400-meter distance corresponds to approximately a 5-minute walk and is used by many local and regional planning authorities as a benchmark for access to green space in the region. And the 1,000-meter buffers correspond to approximately 10 to 15 minutes of walking, and are often commonly used within walkability and environmental exposure literature. So the centroid or centermost point of each 6-digit postal code was used as a starting point for the creation of each buffer. So this is a common method in environmental epidemiology, as it allows for greater de-identification of respondents or research participants' specific location. So in an urban area of Canada, these postal code centroids are within 200 meters of the corresponding residential location in nearly 90% of addresses, and therefore make for a reasonable location proxy while increasing the protection of confidentiality of respondents. So in urban neighborhoods, a postal code will typically correspond to one side of a city block or a single high-rise building. And across urban and rural postal code areas studied, there's a median population of 19 and a mean of 41 residents, with rural postal codes tending to be larger and having a greater population attributed to each postal code in more rural areas. So in the figure here on the left is an example of a circular buffer, which was created using a straight line radius of 400 meters or 1,000 meters centered on each postal code centroid. And on the right is an example of a network buffer, which were applied as well to the centroid of each 6-digit postal code. These buffers incorporated the existing pedestrian road network developed in the Health and Community Design Lab, with the pedestrian road network data set including all pedestrian accessible road segments, including roadways with existing sidewalk infrastructure, including paths or walkable road shoulders, and all controlled access roads, divided highways, dual lane roads, and on and off ramps. Whereas all controlled access roads, divided highways, dual lane roads, and on and off ramps were excluded from this walkable network. And this figure comes from a previous publication. So these visuals show plots of the strength of Pearson correlation coefficient between these various metrics, with larger dots indicating a stronger relationship. And the direction of the relationships are colored, with blue representing a positive and red representing a negative relationship. So boxes with no dots indicate that there is no statistically significant relationship. So here are the correlation coefficients of the relationships between the various GREENSPACE metrics. So here are the 4 main GREENSPACE metrics: park count, tree canopy, NDVI, and total green, which, if you remember, is the aggregate measure of the 5 green or vegetative land cover types, as well as each of those 5 green land cover types displayed individually. So if you look at these figures overall, you can see that there is a moderate to high correlation between total green and NDVI and tree canopy, ranging from about 0.6 to about 0.8 for total green and NDVI. And I've highlighted here the major difference in relationships when you compare the results from the circular to the network buffers. So as you can see, the correlation coefficients between park count and total green land cover type and NDVI move from being weakly positive when using the circular buffering method to weakly negative when using the network buffering method. And these findings show that using a measure of total green land cover, average NDVI, or tree canopy result in somewhat similar GREENSPACE exposures in the Metro Vancouver region. However, quantifying postal code level GREENSPACE exposure through the number of accessible parks, so through the park count variable, has dissimilar results. And the relationships between park count and the other GREENSPACE metrics were most sensitive to the choice of buffering method. So here's a close-up of the 4 maps I showed previously. So here you can see that the variation of the GREENSPACE metrics across just a few neighborhoods rather than an entire city. So on the top, you can see the land cover type. So remember, that's the 12 different land covers, 5 of which are categories of vegetation. Next, there is a map of the NDVI values, with darker green indicating higher positive values, closer to +1. Next is tree canopy cover, with darker green, again, indicating a greater percentage of area covered with tree canopy. And last is park location, where green represents the location of a park or public open space. And so here, if we compare the same location, so which you can see circled in red, this kind of represents the values for a kind of representative 400-meter network buffer. So there is about 31% of the buffer area is covered in aggregate green land cover type. The NDVI is about 0.5, indicating a moderate amount of vegetation, but not particularly dense. There's about 15% of the area covered in tree canopy, and there's one park within the buffer. Here, the land cover type, NDVI, and park count are pretty close to the median values across the region, whereas the tree canopy is below the median regional value. So indicating that this postal code has less than average tree canopy. But this is just an example to show you how these values vary across some more localized areas and how there tends to be some variation between these values. All right, so this is the final poll question. So now that you've thought a little bit more about these various green space metrics, I would like to ask you again, which metric would do you think would be best to quantify the level of green space in an area? All right, that's interesting. I think land cover type became more popular after you heard a bit more of the descriptions. So that's interesting to know. All right, so here is a table that summarizes the descriptive statistics of the 4 green space metrics analyzed in the study. So again, there's park count, including only parks greater than 1 hectare in size, a proportion of tree canopy cover, proportion of total green, and the average buffer NDVI. So each of these metrics were measured at 1,000 meters and 400 meter buffers using both circular and network buffering methods. And as you can see, there was a wide range of values across the Metro Vancouver region. So for example, tree canopy cover values range from less than 0.01 for the 400 meter and 1,000 meter buffers, whereas other postal codes, nearly the entirety of the buffer was covered in tree canopy. And then if you look at this column here, this shows the correlation coefficient values for the relationships between the green space values when using the circular and the network buffering methods were compared. So here you can see that for all green space metrics, the correlations between these results for circular network buffers were higher at the 1,000 meter compared to the 400 meter distance, indicating that there's a greater degree of similarity between these methods at greater distances. However, there's a fairly large, the results for circular and network buffering methods were highly correlated for tree canopy, so at 0.9 for 1,000 meters and 0.86 for 400 meters, whereas the results for circular network buffering methods were only moderately correlated for park count at 0.66 for both 1,000 and 400 meters. In addition, the correlation coefficients became stronger, so about 0.8 at the 1,000 meter compared to 0.54 at the 400 meter buffering distance for NDVI. So this indicates that the results for some green space metrics are more sensitive to the buffering method used and the distance that they're measured. All right, so here's another set of plots using the same scale as before. So this here is comparing the 4 major green space metrics: park count, NDVI, total green, and tree canopy, and the respective correlation coefficients with the walkability index, social and material deprivation index. So the walkability index includes 4 component measures, which were intersection density, net residential density, commercial floor space ratio, and land use mix. And social material deprivation was measured using data collected in the 2016 Canadian National Household Survey. So social deprivation includes the proportion of the population 15 years and older who live alone, or lone parent families, or who are separated, divorced, or widowed. While material deprivation includes the census dissemination area average income, proportion of individuals without a high school diploma, and proportion of unemployed individuals. And as you can see, the patterns of relationships are predominantly similar but stronger at the 1,000 meter compared to 400 meter buffer distance. So park count was weakly associated with walkability, with this negative association at 400 meter buffer distance, shifting to a positive relationship at the 1,000 meter buffer distance. And all other measures of green space, so land cover type, NDVI, and tree canopy cover were negatively associated with walkability. And in this study, social and material deprivation index values were moderately negatively associated, which supports previous research suggesting that these two measures should be considered separately rather than as a composite deprivation index. In addition, you can see that social deprivation was positively correlated with walkability, indicating that greater neighborhood walkability was associated with greater neighborhood social deprivation. While there was a weak to moderate negative correlation between social deprivation and green space. In terms of material deprivation, this factor was weakly to moderately negatively correlated with walkability, NDVI, tree canopy, and total green, while there was no significant relationship between material deprivation and park count at the 400 meter distance, and a weak positive correlation between material deprivation and park count at the 1,000 meter distance. So previous work has typically shown a lack of strong relationship between natural land cover types and park access in Metro Vancouver, as well as other cities. And these current findings are consistent with park access not being highly correlated with other green space metrics. Previous work has found that neighborhoods with the highest NDVI values tend to be more car dependent, whereas the most walkable neighborhoods have lower average NDVI. Similar relationships between walkability and NDVI were seen previously in Vancouver, with negative correlations also reported in other US and Canadian cities. So this project contributes to the existing knowledge regarding the lack of strong association between various green space metrics commonly used to quantify exposures, often used to predict health outcomes in environmental epidemiology. Previous work has compared circular network buffering methods, but not across these 4 green space metrics. So these findings may provide evidence for researchers when determining which buffering methods is most appropriate for their specific research questions, and which types of green space metrics may be most influenced by buffering method choice. The use of multiple green space metrics to determine association between walkability and green space is also novel in this paper. However, the study does have limitations. The results may not be generalizable to other diverse urban and rural areas. And in addition, the comparison of additional green space metrics, so such as reported or perceived green space exposure access or additional measures of biodiversity, were not within the scope of this project, but would be considered important to be considered in the future. So future work using green space as an environmental exposure should be intentional about which green space metric and buffering method most accurately estimates the potential pathway by which green space is hypothesized to impact human health. So by the selection of buffering method may be particularly influential when park count rather than tree canopy, NDVI, or land cover data is utilized to quantify green space exposure. So this is important as the use of circular buffers may overestimate the accessibility of green space or the likely exposure during local outings, as this method does not consider potential obstacles such as a highway or a water course, which may impact the accessibility of these areas. Future work should also examine the differences in green space metric results when using circular and network buffers in other diverse geographic areas to determine if the same relationship is found. In addition, future work should consider how postal code level walkability, green space exposure, and deprivation relate to health outcomes. Additionally, these measures can be tracked longitudinally to better understand potential causal relationships. The finding that areas with greater social and material deprivation tended to be associated with lower green space indicate that these areas may benefit from investments in additional green space. The identification of neighborhoods with higher material deprivation, low walkability, and low green space should be prioritized by urban planners and decision makers as possible locations for additional green space allocation. In already developed areas where large park spaces or dramatically altering the built environment may be impossible to quickly implement, more micro-scale pedestrian and green infrastructure investments may be more feasible. So in areas with greater material deprivation and limited green space, it may also be important to consider the potential impacts on land values associated with incorporating additional green spaces and to attempt to reduce any displacement of existing residents. Future work may also strive to better understand the role of smaller scale green space investments and the associated impacts on residents' health, as these may support decision makers in determining how to best allocate green space throughout the city or region. All right, so I would like to thank you for joining in and listening today. I look forward to addressing any questions or comments you have. I would especially like to thank my research supervisors on this project, Dr. Kate Weinberger and Dr. Lawrence Frank, as well as Dr. Trevor Dummer and Dr. Hugh Davies, who were my thesis committee members. I'd also like to thank my colleagues at the Health and Community Design Lab, with special thanks to Connor Wolf, who helped with the data preparation and preparing the maps you saw on this presentation today. I'd also like to thank the partners of the Where Matters to Health and GHG Impacts of Transportation and Land Use project for supporting the larger project for which this work will contribute. And in particular, thanks to Metro Vancouver for collecting and providing access to environmental and land use data across the region. And now I'm happy to take any questions or comments. I've also left my email there if you have questions that come up later on. Thanks.
Thank you very much, Katherine, for the presentation.